Okay, today we're going to talk about a last section of factoring notes for the chapter. We combine 8.7 and 8.8. We talk about some factoring special cases. Now the thing about factoring is once you get good at it, then we just start throwing everything at you. Let's see what you can, if you can figure out what to do, when to do it, and hopefully you can do it well. So I got a couple special cases sitting on this paper for you. Let's see what we can do. Now, let's take a look at the first one. You notice the first one's different than any one we've done before. And the reason why that is you'll notice that there's not just x's, but there's x's and y's. Okay, and that causes a little bit of a problem, but not too much. You know, a lot of us, let me take this little magic sheet of paper here, and if I were to take this little piece of paper and stick it right there, and then take this one and stick it right here. Okay, most of us would know how to factor that. What if we did factor that? 3x squared plus 16x plus 5. How would you do that without the y's? Well, we would start with our parentheses. Factors of 5 are just 1 and 5. Factors of 3x squared are just 3 and 1. And so since we don't have too many choices, it's plus and plus, obviously, because this is plus and plus. 5, this is 1. And so what would you use over here? Well, I would use the 3x, and I would use the 1x. And just to check, remember it's the inside terms, so that'd be 1x plus the outside terms. That's 15x, which adds up to 16x. So I did it correctly. Well, that wasn't too tough, but remember I actually inserted those little sheets of paper. So how do I do that? Well, there's no real trick to it. It's actually quite easy. Let me zoom in just a little bit for you. Instead of using 1 and 5 here, okay, just like how instead of using 1 and 3, you actually use 3x and 1x. Over here it says 5y squared, so what you're just going to use is you're going to use 1y and 5y. Now, how does that change things? Well, it doesn't really change things too much. When you do 1y times 1x, that's just 1xy. When you do 3x plus 5y, it's just 15xy. And same or like terms, so you can add them, 16xy, and that's what we were looking for. So there's not a whole lot different. The only thing different is that for this term, when you use your factors, you just have to insert a y. Okay. Really, that's as difficult as it gets. And that's kind of the trick to that one, is that people who don't know what they're doing think those are really difficult. But those of us who do know what we're doing realize that they're actually quite easy. So let's do one more. Here's one. Great chance for you to hit pause and give this one a shot on your own. If it helps, we can just go back and do exactly what I did before. If you were to cover up the y on both of these and factor it just like you would normally, I would start here with my parentheses. Now notice it's a minus sign here, so that means we're going to have a plus and a minus. Factors of 7 are 1 and 7. Factors of 4, now I have a couple choices. I have 1 and 4, and I also have 2 and 2. So hopefully you're starting to get a little bit better at this, and you can maybe get a feel for which ones you want to use. I'm going to decide to use 2 and 2 here. So I'm going to write 2x and 2x. And the question is, with my 1 and 7, where do I want to put the 1? Where do I want to put the 7? Well, I'm going to choose to put the 7 here and the 1 there. Because when I check, multiply those together, I get 14x. Multiply these together, you get negative 2x, which adds up to 12x. And that's what I was looking to do. But again, we actually have y's in there. So instead of this being 1 and 7, this means this has to be 7y and 1y, which would make this 14xy. And this would make it 2xy, 12xy. So it actually does work. So if it helps you, go ahead and cover up those y's. If you get comfortable with it, then you know it's a piece of cake. You can just, instead of writing 7 and 1, you just write 7y and 1y. And there you go. We factored it. So that's our first special case. Let's move on. Second special case that I want to talk about is this one. Now this one looks pretty, normal, typical, I guess. And it really is. This one's, even though it's considered a special case, isn't really that fancy, to be honest with you. Let's just go through and look to factor. Now, what might be challenging is that this actually has some bigger numbers, but let's start listing them. Let's see, we have 1 and 25. We also have 5 and 5, and that's actually it for that. This one over here, we have 1 and 9, and then we also have 3 and 3. So, what can we put in here? Let's see, we have pluses here. That's good. Thoughts on what we could use? Well, hopefully you're kind of crossing out 1 and 25, because I'm thinking when I combine 1 and 25 with either 3 and 3 or 1 and 9, I'm going to be a lot bigger than 30. So I'm going to use 5 and 5 right here. Now over here, if I were to use 1 and 9, I got a feeling I'm going to get a pretty big number, because 9 and 5 would be 45. So I'm actually going to use 3x and 3x. So let's check ourselves. And hopefully you're kind of getting to the point where you can do this check in your head. I like to write it out, but you don't have to if you're good at it. So if I check those, you notice it does add up to 30x. That's what we want. So what makes this a special case? Well, the fact that my factors, if you notice, are identical. So a simpler way to write the answer, instead of writing 3x plus 5 times 3x plus 5, is to simply just write the quantity of 3x plus 5 squared. Now, is it wrong if I were to write that out completely like that? No, it's not wrong. This is a little more efficient, and so just be aware. If you have an answer like this, feel free to write it like that. Or if you see someone else's answer that looks like this, just understand that that's the same thing as yours if you wrote it out like that. Okay, last type here. Okay, so let's move on down. I got two examples I want to talk about. So what I want you to do is I want you to just take a second and look at all three of these terms right here. And what do you notice about all three of those terms? Well, hopefully you said to yourself that they all have a factor of 4. So if you remember way back when we first started factoring, the very first type of factoring we did was monomial factoring. So there are times where you're going to actually have to do multiple types of factoring. So for instance, here, you notice that I can actually factor out a 4. So I'm actually going to factor out a 4. So when I do that, I get x squared. Take it out of here, I get 6x. Take a 4 out of this, I get 5. Okay, and so I have two factors. I have this one, and then I have this one. But you need to look and see and check, can I factor one of my factors? Well, yes, I can. I notice here that I can actually factor this even more. So I'm just going to bring the 4 down. Okay, so factors of 5 I want to use, I'm going to use 5 and 1. They're plus and plus, so I'll put plus signs in there. And this is an easy one. Factors of x squared are just x and x. And so there you go. I've completely factored it. Okay, I have a factor of 4, a factor of x plus 1, and a factor of x plus 5. Now, something you might be thinking to yourself or asking yourself, do I have to do that? Do I have to factor out the 4? Yes, you do. That's why way back up here, this phrase or the instructions were factor completely. So that means you need to take out all the factors. And so this is something that's going to come up a lot. You need to look, and every single time that you look at a trinomial or anything to factor, you need to be thinking or asking yourself, what could I do? And then factor it completely every single time. Can you do a monomial? Can you just break it into binomials? Whatever, but you need to do it completely. All right, last one. Okay. Again, I don't expect us to be perfect at this, but hopefully we're getting the general idea. So let's take a look at this one too. This is going to be similar to number 4. What do you notice that all three terms have in common? Well, they all have an x in common, but they also have a 2. So we could actually take out a 2x this time. So when I take 2x away from 20x to the third, I get 10x squared. Take a 2x away from this, I get minus 13x. And 2x away from negative 6, I get negative 3. Okay. Now that would be great if we were done right there, but I got a feeling we're not. So we're actually going to have to factor some more. So I'm going to bring the 2x down again. Break this up. So if it helps, list your factors. We got 1 and 3 right there. Over here I see we have 1 and 10. We have 2 and 5. It's a minus sign here, so that means one's going to have to be plus, the other one's going to have to be minus. So then the question becomes, what do we use? Well, you know, you might be thinking to yourself 1 and 10, since 10 and 3 is 13. But the problem is that you're going to have to do, one's going to be positive, the other's going to be negative. So you're not going to get the negative 13. So I am actually going to suggest we use 5x here and 2x there. And then for my factors over here, I'm going to use 3 here and 1 there. Now, how do I know that? Well, because I've done these a ton and I'm pretty good at them. Now, you might have gone and made a different suggestion, and you have to go through and check yourself. You know, make sure that when I multiply the inside numbers here, okay, so that's 2x. This is negative 15x, which adds up to negative 13x, which is what I'm looking for. So if you did something different and it doesn't add up to negative 13x, then you got to go back and fix it. Remember, when we do some factoring, there's only one solution. There's not multiple ways you can do it. So what does that mean? Well, that means my final answer is 2x times the quantity of 5x plus 1 times the quantity of 2x minus 3. And there you go. So it definitely can get a little complicated. You definitely will have some problems that will involve multiple steps. Well, you just have to keep at it. As I said in a previous set of notes, it's not an exact science. You just got to keep plugging away at it. So, as always, if you got any questions, write them down, make a note to yourself, and then we'll talk about it when we get into class. Okay? Thank you.